Hi, my name is Vivek Jhaveri. I'm the development lead for the Microsoft Management Console. In the Whistler timeframe, we've added enough features to Microsoft Management Console that it qualifies as a major release. This talk is targeted primarily towards Snap-in developers. Also, if you're a system administrator or somebody that handles the setup of your management application, you might find things in this presentation that are interesting to you as well. I'm going to go over the most important new additions to MMC 2.0 and cover some of them in more detail. There are also a variety of other enhancements that won't be covered over in this, which qualify as design changes or minor changes. The main points of interest are the new MMC 2.0 automation object model. MMC 1.0 and 1.1 and 1.2 didn't offer very much by way of automation support, but that changes completely in MMC 2.0. We've added complete support for controlling MMC through Visual Basic, C++, and other automation clients. There have been a few new Snap-in interfaces. We've added interfaces for managing Snap-in power requirements and for view extensions, which is a new extension mechanism, which is the next point. Also, the console file format has changed from what it used to be in MMC 1X, from an opaque format to XML. This provides for a variety of advantages, which I will go into in a little detail. And there are also some miscellaneous UI enhancements. The MMC 2.0 object model came as a response to a variety of needs expressed by users and by Snap-in developers as well. In MMC 1.2, we provided automation support for writing snap-ins through the VB designer. In MMC 2.0, this goes one step further by allowing MMC itself to be controlled through Visual Basic or through any other automation client. We expose a rich set of objects through the object model, as well as a rich set of events that can be used for script or for applications written in Visual Basic to react to things going on within MMC. So some of the scenarios in which the object model would be very useful are one situation expressed by some management application deployers was the ability to create console files on the fly in complex setup scenarios. If your application needs to install a set of snap-ins that depends on the situation in which the installation is occurring, and needs to install a different set of snap-ins in another situation, you might find this capability useful. Through the object model, it is possible to invoke MMC, add a set of snap-ins, and create a console file, customize your views, and then save the console file all on the fly with MMC running invisibly if you so desire. This allows console files to be created on the fly and avoids any problems with having references to snap-ins that have not been installed on the user system. In addition, system administrators might find the ability to automate frequently used tasks quite useful. Because it is possible through the object model to navigate down to any node or to add in any snap-ins or to invoke tasks on the context menu of an item, all through script, it becomes easy to do this repeatedly through script based on, for example, a set of items in an Excel file or any other source of input. The other advantage of using the object model is in situations in which UI, like property sheets and wizards, needs to be invoked with MMC running invisibly. Snap-in developers have invested a good deal of time and effort in creating rich property pages and wizards, and often have expressed the need to use these wizards and property sheets in places other than with the MMC UI. By running MMC invisibly and navigating directly to a node and displaying the UI, this becomes quite easy through the object model. Finally, the object model can be used within HTML, running in the result pane. And the new view extension model, about which I will go into in a little more detail, uses this feature quite extensively. So imagine, if you will, HTML in the result pane that uses the object model of MMC to react to events that the user does, to actions done by the user, and potentially display interesting UI or provide other information, for example, that's not provided directly by the snap-in. So a little more about the object model. Like most object models, the MMC object model can run out of proc, or if the client is HTML running within the result pane, it is an in-prop automation server. In either case, the root object is an application object, which exposes a variety of objects underneath it, as well as a rich set of events through the app events interface. The document object corresponds to the console file itself, which exposes a views collection. A view can be thought of as the object model metaphor for an MDI child window. And the view object also exposes the selection, which is the set of list items that have been selected in the result pane. In addition, the scope namespace exposes the tree, the main console tree through which it becomes possible to navigate down all the nodes of the namespace. The snap-ins collection represents the set of snap-ins that have been loaded into the current console file. So through script, it becomes possible to add and remove snap-ins and to enable and disable extensions individually. There are also a couple of other objects about which I won't say very much, such as context menu, menu items, the columns, and properties objects. Some of the new interfaces that are exposed in MMC for snap-ins to implement if they so desire include iContext menu callback 2. This is an incremental addition to iContext menu callback, which was exposed in earlier versions of MMC. It allows snap-ins to specify a single new field for context menu items added in by snap-ins, which are language-independent names for menu items. The reason that this seemingly simple addition makes a lot of sense is that script can now invoke context menu items using the language-independent name and thus not rely on which language a snap-in has been localized for. All MMC built-in context menu items have language-independent names, so it becomes easy to use these right out the box. In addition, now that MMC has provided a rich object model, it is also easy for snap-ins to extend this object model and thereby support script and scripting for almost free. In MMC 1X, the interfaces iComponent and iComponent data both had methods called query data object, which essentially allowed the MMC to obtain an object that represented a node or a set of nodes. MMC 2.0 takes this idea one step further by defining the methods query dispatch on the interfaces iComponent 2 and iComponent data 2. In parallel with query data object, query dispatch asks snap-ins to provide a dispatch interface that represents the node or the set of nodes in question. This is fairly simple to implement, but this is really all that MMC needs to allow snap-ins to chain into the MMC object model. By doing so, a user could, for instance, open up a console file, navigate down to a particular node, and if, for instance, the node in question belonged to a snap-in that supported the iDispatch interface, exposing a method, for instance, create user with a certain set of parameters in it, then through script, the user could open up MMC, navigate down to the node, and invoke the method create user with whatever parameters were necessary. So MMC no longer is just a container for UI provided by snap-ins. It also now becomes an easy way for snap-ins to take advantage of the rich automation capabilities of MMC 2.0. Another new interface is the iComponent 2 interface, which I talked about a little briefly a couple of minutes ago. And another couple of methods on it are getResultViewType2 and RestoreResultView. The rationale behind defining these two methods in MMC was that customers had asked, snap-in developers that is, had asked for a way to restore views with greater precision than was possible with MMC 1X. And getResultViewType2 now allows snap-ins to create views and hand in a textual description of the view. And when the view needs to be restored, for instance, when the user closes a console file and reopens the console file, MMC needs to recreate the same view. Another scenario is when the user uses the back and forward buttons to navigate to different views and back. At that point, MMC uses the textual description that it had saved and hands it back to the snap-in. And the snap-in can use this textual description to restore the view to as precise a rendering as it wishes to. In addition, getResultViewType2 allows snap-ins to create OCXs and hand an interface pointer back to MMC. In MMC 1X, if a snap-in required an OCX in the result pane, the snap-in would pass MMC the class ID of the OCX, and MMC would then create the OCX. This was limiting for a couple of reasons. One was that snap-ins were not free to reuse the OCX as and when they wished. MMC 1X had a fairly simple OCX caching algorithm. And secondly, it became difficult to use licensed OCXs within MMC. By allowing the snap-ins in MMC 2.0 to create the OCX and hand it to MMC, it becomes possible to solve both these problems, because now OCXs can be cached exactly according to how the snap-in wishes to. If a snap-in wants to use the same OCX again, it merely hands the same interface pointer back to MMC for another node, for instance. And a snap-in is now free to create a licensed OCX using any license keys shipped in with the snap-in and hand the resultant OCX back to MMC. There's also a couple of power management interfaces that were shipped with MMC 2.0. These came out of a request for snap-ins that had complex power management scenarios and, for instance, needed to interact with the system during hibernation and other power management events. So MMC can now handle the WM power broadcast message sent by the system appropriately based on information supplied by snap-ins within a console file. There's a couple of questions at this point, which I'd like to... Okay, I guess that was a test question. There's also, coming back to the new interfaces in MMC, there's also a new interface which can return the version of MMC that's currently installed on the system. This is a useful and guaranteed way of being able to determine what version of MMC is running on the system, and the interface is IMMC version info. And for versions greater than the current version, it will return the version number of MMC. Moving on to view extensions. What you see before you is a screen that contains, believe it or not, the standard services snap-in. You may be asking yourself at this point what the UI, which looks very much like Explorer to the left of the list pane, is. Well, that has actually been provided by a view extension, which was written entirely independently of the services snap-in. So To put it simply, a view extension is an extension snap-in. It's a new extension type, similar in that sense to property page extensions, context menu extensions, and toolbar extensions, um, which allows additional UI elements to be created in the result pane. It is completely HTML based, and the HTML can take advantage, as mentioned earlier, of the object model, which this particular example does rather heavily, and can display UI that's very reactive based on what the user is doing. So we can see a particular service, the Complex Event System service selected, and on the left, a description of that service and a few details about it, as well as a couple of actions a couple of links to stop and restart the service. So to give you a little insight into how this was done, a standard view extension was created to extend the services node, and the HTML view extension HTML is able to embed the result pane of the snap-in that's being extended right into the HTML, which is why you see this, the list of the services node being embedded alongside the HTML. The HTML, incidentally, you may see the resemblance to Explorer, which is precisely what this particular example was modeled on. And in this case, when the selection changes, the HTML reaches out into the object model and pulls out certain values from different columns and reassembles them to provide the description and details. And in addition, also looks into the context menu, finds out what menu items are enabled, and that's how the stop and restart actions are available to the user directly from the HTML. So to reiterate a few of the points that I just made, view extensions are a new snap-in extension model, just like property pages and context menu items and toolbar extensions were in MMC 1X. Snap-ins that wish to be view extensions need to implement just one method on the interface iExtendView. The method is getView, which essentially returns a URL to an IE5 DHTML page. And this DHTML page is most often located within the resources of the DLL, but need not be. As mentioned before, view extensions can embed the result pane of the original snap-in within the HTML, but don't have to. Also, view extensions can add more than one result pane at a time. If there is more than one, then the user can switch between the result panes provided using a tabbing mechanism. The DHTML can execute script that accesses the MMC object model using the IE5 external object and can react to events fired by the object model. So if you're a snap-in developer, you should be thinking about how you can use view extensions to enhance the look and feel of your snap-in. If you're a third-party vendor that provides extensions to existing snap-ins, you can start thinking about how you might want to integrate UI that you create with the UI of the snap-in that you're extending. The view extension that you saw in the example is actually a canned view extension that ships with MMC 2.0. We've decided to call it Explorer View for its similarity to Windows Explorer. To use Explorer View with your snap-in, all you really need to do is register Explorer View as an extension to your snap-in. That really is all that you need to do, and you will see it appear in the result pane alongside your snap-in's UI. In addition, if you would like to add contextual information based on an item selected in the result pane, all you need to do in addition is implement one clipboard format. Moving along to the next feature in MMC 2.0, the XML console file format. From time to time, people have requested the ability to be able to change what's in our console files for one reason or the other, and have not been able to do so really because because in earlier versions of MMC, the console file format was binary. It was very opaque. For that reason and for others, we've moved the console file format to XML, and it can now be edited and manipulated using any of the standard XML tools. So some of the advantages of this are the console file formats are extremely easy to edit. Localization is a big advantage. If you're a Snap-in developer and so far have had the necessity of creating multiple console files based on the language of the Snap-in that you were shipping, you might find an easier way to do it is to create one console file, and using whatever localization tool you use to parse the XML using a standard XML parser and localize it using this way. In addition, because the XML files are essentially text, they can be checked into a source code control system and carefully diffed. In addition to being able to use the object model to create console files on the fly, it's now also possible to do some customization directly on the console file using XML tools. It's entirely feasible to produce a template of a console file and then customize it on the fly. For example, in the same complex setup scenario outlined earlier, by editing the console file directly. Naturally, MMC 2.0 will continue to read older format binary files. One feature that was requested to a good extent by Snap-in developers was the ability to get extensive error information from MMC. Thus far, MMC has returned fairly general purpose, fairly generic error codes when the Snap-in made an incorrect method call, for instance. In the Whistler timeframe, MMC 2.0, the debug builds of MMC 2.0, which will ship with the beta and with the released versions for developers, will contain rich debugging support in the form of traces, which make it easy to identify exactly why a method call into MMC failed. This also makes it easy to locate errors, for instance, calling an MMC method from the wrong thread, and other cases which are usually fairly hard to debug. There's a new debug trace dialog. Again, this is only in the debug builds of MMC, which can be invoked using a special hotkey in which traces can be individually turned on and off. Finally, some UI enhancements to MMC which have been done in the 2.0 timeframe. The toolbars and menu bars which were formerly in the MDI child windows have now been moved to the main window to make MMC more in line with some of the other Windows applications. Flicker has been significantly reduced. The favorites pane, which sat alongside the tree in MMC 1.2, has now been removed. Users can still access favorites through the favorites menu. So to go over some of the points that I made earlier, and also to start you thinking about what you could be using MMC 2.0 for. If you're a Snap-in developer, start thinking about how you might want to use the MMC 2.0 object model, about whether you would like to chain into the MMC object model. While writing an automation server is typically a fairly complex and challenging job, MMC has done most of the work for you, and really all you need to be able to do is support a single iDispatch interface for your Snap-in. And MMC does the rest and provides a rich set of objects and events, and with an easy to understand UI metaphor for script writers to use. In addition, think about whether the XML console file format can be of use to you in your setup and deployment scenarios, and also in your localization scenarios. Finally, I would urge you to use iContext menu callback to supply a language-independent name for your context menu items so that script writers that wish to invoke your snap-in through script can do so easily without having to write script that is different depending on the language of your snap-in. The power management requirements, if any, can be as before handled through the iConsole power interfaces, in general, try to see whether view extensions would be a good way to go for your snap-in or for your extension. If I have a couple of questions in the next couple of minutes, I could respond to them. All right. I guess there are no questions, so thank you very much, and I hope you've enjoyed this presentation.